Good afternoon, everybody. Welcome to the Michigan Historic Preservation Network webinar series. My name is Xianghan Bao Smith. I'm the Historic Properties Coordinator of MHPN. We are very excited today to have our speaker, Michael Smith, to talk about Albert and Julius Kahn inventing the modern factory. And before we get started, I would like to go over some Zoom items. If you have any questions, please type them in the Q&A box as you think of them, and we will be answering all the questions at the end. And feel free to use the chat box to share your thoughts and resources. And please participate in the survey after this webinar concludes. If this is your first time attending our webinar, we are the Michigan Historic Preservation Network. We advocate for Michigan's historic places to contribute to our economic vitality, sense of place, and connection to the past. We cannot do the work we do without our members and volunteers. So if you're not a member yet, please consider joining us at www.mhpn.org. This webinar series is sponsored in part by Michigan Council for Arts and Cultural Affairs. We want to give a big thank you to our sponsors. And it is my great pleasure today to introduce our speaker, Michael Smith. Michael is an architectural historian and author. He is the author of Designing Detroit, Ward Roland and the Rise of Modern American Architecture, an award-winning history of Detroit's early 20th century architectural achievements. He has had articles on Albert and Julius Kahn published in the Journal of the Society of Architectural Historians, Michigan History, and Michigan Jewish History. Michael wrote the nomination that placed the Detroit Savings Bank Southwest building designed by the Kahn's office on the National Register of Historic Places. And with that, I will turn it over to Michael.
Thank you very much. I'm certainly happy to be here, and I appreciate your organization being open and interested in hearing what I have to say, and I hope that everybody enjoys it. And without further ado, why don't we go ahead and get started here. I will share my screen. What are you seeing right now? Not my screen, probably, right?
I have not seen it yet. Maybe it takes a while to react.
Yeah. Okay, there we go. How's that look?
Yep, looks good.
Okay, good. I think that given the audience today, most of you probably are familiar with Albert Kahn. Hopefully you'll learn a little bit new about Albert and probably a little bit new about his brother Julius. I'm mainly going to talk about how the two brothers combined to essentially reinvent the American factory. And to get us started on that, let's talk about the factory as it existed around 1900. At that point in time, almost every factory in the country was of what was called mill construction or slow burning construction, which was a type of building that was a slight improvement on the traditional brick and timber construction of nearly all buildings prior to that point in time. And you can see in this this image here that it's essentially a wall-supported building. You have the brick walls on the exterior. The walls towards the bottom of the building are thicker to support the weight above. The floors are supported by wooden beams and wooden columns. And clearly, when you have that type of structure, you have a clear threat. If a fire were to break out, it's very unlikely that the building can be saved. So you have two potential issues. One is the danger to people that they can be injured or killed by fire. The second is the damage to the business that occupies the building with the destruction of their equipment, their inventory, their plans, their accounts, just about everything that's important to a business. Second problem with these buildings is that because the exterior brick walls supported the building, the addition of windows obviously weakens the wall. So you've got a trade-off there. If you want larger windows to admit more light into the building, then you have to have thicker walls that are more difficult to construct in an efficient manner. And the windows were important for illumination because obviously at the time, the efficiency of industrial lighting was very, very low. The typical lighting used was an incandescent light bulb, which didn't really give off the amount of light that we normally see in a building today. And finally, an important consideration is that as industry improved, got larger, began building bigger objects, such as automobiles, trucks, and so forth, the machine tools used to construct these items were much larger and heavier than what had been seen in the centuries prior to that, and that tended to result in buildings that vibrated, and as a consequence, the machine tools couldn't operate as efficiently and tended to wear out much more quickly. So generally speaking, you had a very inefficient type of structure at a time when the industrial productivity of the country was rapidly increasing. Now, to give an example, this is the Michigan Stove Works building, constructed in 1890. It was a very typical type of structure that was used for industrial production at the time, around 1900. It's a mill construction building with exterior bricks supporting walls and interior framework of timber and wood, wood floors, wood joists, and so forth. It was not the most efficient building, but it generally was a function of architecture at its time. And also should mention that Michigan Stove Works was the largest stove manufacturing company in, at least in the country, if not the world. Now, not long after the building was constructed, it was deconstructed. As you can see here, the massive building that you saw on the previous slide has been really reduced to not much more than an angular piece of brick from one corner of the building jutting up. And also, if you look over here on the right, you can see a second building that's been gutted. And in this case, gutted is literally the correct word for what's happened to this building. All the timber within the building and everything else that was in the building has been burned out and turned to ash. So that was the essential problem faced in the early part of the century. Now, as you well know, Detroit was the home base for the rapid development of the automobile industry, and the automobile industry is highly susceptible to destruction by fire. And you can see two of the casualties here. The Cadillac automobile plant was destroyed in 1904. The Oldsmobile Motor Works, the original building you can see in the lower right corner of the slide here, and you can see what happened to it here in 1901. It was essentially leveled to the point of what you see here, within about 15 minutes, completely destroyed by fire. Now, this was a very common occurrence around 1900, and as a consequence to these tremendous fire losses, the insurance company that insured buildings and their contents against loss by fire were forced to either go out of business, refuse to write fire insurance, or they dramatically increased their fire insurance rates, in many cases by 25%, which clearly you can imagine had a tremendously cooling effect on the ability of companies to continue to operate businesses that involve manufacturing, warehousing, or retail within large mill construction buildings. Now, the solution to that, as some of you may be well aware, was the work of the Kahn family, primarily Albert and Julius Kahn, but all of the Kahn family members that you see here, with the exception of Paula, at one time or another worked for one of the Kahn businesses. And we're going to primarily follow Julius and Albert, but Felix, Gustav, Moritz, and Louis all ended up at one time or another either working for Louis or working for Julius or working for Albert at some time in their careers. First, we have Albert Kahn. He was born in Germany in 1869. He emigrated with his family to the United States in 1881. Albert, being the oldest, really had much more responsibility for helping to establish the family in the U.S. and support the family in some form or manner. So he left school in the 7th grade and went to work for George D. Mason, one of the city's leading architects, and he did quite well working for George Mason. Albert was a very forward-seeking and bright fellow. He was also very ambitious, and probably by reading the local paper, he was able to determine not only that more factories needed to be built as industrialization expanded rapidly. That didn't take a great deal of insight, but he understood that the factories would need to be far more complex, that they'd need to be more customized to the particular needs of the company that was using them. And he realized also, quite importantly, that architecture and architects would be largely displaced by engineers and engineering in the design of these larger and more complex factories. And in an effort to get out in front of that trend, and both to avoid being pushed to the side by engineers and to acquire much more profitable business in designing factories and industrial type complexes, he did something that was relatively unprecedented. He hired, or I guess I should say more accurately, he partnered with his brother, Julius Kahn, a very skilled and experienced civil engineer. Julius, unlike Albert, was able to attend college and acquire there a degree in civil engineering. He was able to do that in part because his education was financed by his brother, Albert. After leaving school, he spent some years working for a bridge company and I believe the Brooklyn Naval Yard. And then he spent a couple of years in Japan as a manager of a sulfur mining company. So he acquired not only business skills, but a great deal of experience in the engineering of steel structures, which he was quite skilled at doing. So in 1902, Albert, envisioning that there'd be a place for a firm that combined both architecture and engineering, invited Julius to partner with him and form the firm of Kahn & Kahn, Architects and Engineers. And this was an important development because it was the first firm in the city of Detroit to combine both architecture and engineering. It was also one of the first in the nation. Generally speaking, architects didn't have engineers on staff. They would job out or hire from engineering consulting firms the expertise that they needed. So Albert had now under one roof the ability to both design buildings and to engineer factories as well. The first major job that the two brothers secured was a factory that was actually quite significant. They had done work for the owners of the Packard factory prior, and as a consequence, we're able to secure this commission. Now, what separated these brothers from many other architects was their understanding, their insight into the significant needs that manufacturing companies had. They needed the factories to be constructed quite rapidly so they could get into business manufacturing quickly in a very competitive environment. That was extremely important. The buildings had to be low in cost because often they were replaced before they wore out. The maintenance and particularly the insurance and fire insurance costs had to be as low as possible. And the efficiency, the production efficiency had to be seen to in a very significant way. In other words, the less handling of materials, the less amount of labor needed by the manufacturers, the lower the cost of manufacturing would be, and consequently, the more profit or the lower price the manufactured product could be sold at. The two brothers combined in designing this new Packard factory in a period of about 3 months, and they did a superb job of designing this factory. It was written up in a number of publications, both for the speed with which it was designed, the extremely low cost of the insurance, particularly the fire insurance, that was facilitated by the nature of the design of the factory. It was also designed with production efficiency in mind, that the workers, when they showed up for work, could enter the building right directly into their workstation rather than having to traipse through the entire factory and provide a distraction to other workers. So it was a very efficiently designed factory from the get-go. And one of the interesting things that I discovered was that this was one of the only design drawings, this one that you see here in the slide, that included both Albert's name as architect and Julius's name as engineer. And the only reason that they would have done this really is to impress upon the customer, Packard Motor Car Company, that both architecture and engineering services have been brought to bear on the design of this factory, a concept that they were anxiously promoting to all manufacturers that they were attempting to get work from. Now, the year prior, the Palms apartment building, which you see here, which still exists, was being constructed on East Jefferson Avenue. This had been designed by Albert Kahn and George Mason when Albert and George were both in practice together in the year prior to Albert joining in a partnership with his brother. And one of the unique features about this building is it was the first fireproof building in Detroit constructed with concrete floors. Typically, the floors of the building would be of wood, and the wood would be laid on top of a terracotta tile in order to achieve fireproof status for the building. Concrete was much less expensive, and it was more effective as a fireproofing agent than terracotta. But there was really nobody that knew how to install a reinforced concrete floor. So Albert hired the Cleveland Silex Stone Company to install the concrete floors. And Cleveland Silex, really their expertise was in sidewalks. And sidewalks, as you know, are typically laid on top of the ground or some other substrate that supports it from below. But in the Palms apartment building, the space between the floor joists, the concrete floor was unsupported. So in order to prevent the floor from cracking and falling through the hole, they added what essentially amounted to a mat of either steel fencing or expanded steel lattice, which generally did the job, but there was really no scientific understanding of how that would work. In other words, how much weight could you put on the floor without the floor collapsing? How thick did the concrete have to be? How heavy duty did the steel, expanded steel lattice have to be? And this puzzled Julius because he was coming from an environment as an engineer where you could calculate the strength or the weight supporting capacity of any material, whether it be timber, wood floor, steel beam, steel truss, steel bridge, stone, brick. It all had some form of algorithm that you could calculate the strength of that construction material. So he asked his brother Albert. He said, "How do you calculate the strength of the reinforced concrete that we're using for the floor?" And Albert responded, "By guess. There's no scientific data." And Julius was just profoundly shocked by this, that you could construct something safely, you hoped, but not know exactly how safe it was. Now, that set Julius loose on an intensive study of what was known about reinforced concrete at the time. And what he discovered was that you could build with reinforced concrete, as was the case. There were a number of architects and engineers that were building with reinforced concrete, and they were doing so by placing these steel rebars within the concrete. You can see this twisted bar here, which was the type used by an engineer by the name of Ernest Ransom. And when these bars were tested by Julius, you can see the bar here. The bar has not snapped, but the concrete beam and floor has collapsed. And it's collapsed because of these cracks that have propagated up through the floor. So there was no way to calculate the strength of the floor because there was no way to calculate how strong the concrete would be before it cracked and tore loose from the steel reinforcing bar. So that was one of the problems that Julius foresaw that he had to solve. Now, here's how he went about solving that problem. He understood, as everybody did, exactly how a beam functions when it's placed under a load, or when weight is placed upon the beam. What happens is the top of the beam is compressed and the bottom of the beam is stretched. As you can see with this drawing, it's maybe difficult for you to picture, but take my word for it, that's exactly what happens. Concrete can't stretch very much, so when it's forced into a position where it has to stretch, it'll begin to crack, and those cracks will at first be microscopic, but later on they'll become quite visible, and ultimately it'll lead to the beam failing. Now, Julius, having worked extensively with steel structures, bridges, trusses, buildings, anything that could be built with steel, typically was often going to use a steel truss. And a steel truss is a girder or beam-like structure that's built up from a series of triangles. Triangles being a very sturdy geometric figure that doesn't even need to be firmly attached at the three corners in order to maintain strength. Now, in a truss construction like you see here, the red parts of the steel are going to be in tension, like you saw on the beam, and the blue parts are going to be in compression. again, just like you saw in the beam. So Julius imagined that you could take a truss like that, you could place it inside of a concrete beam, and the concrete beam obviously would be just as strong as the steel truss because it had the steel truss contained within it. He also realized that you could dispense with all of these blue parts of the beam because they're in compression. And because the steel is completely surrounded by the concrete would be able to absorb all the tensile stresses that are being placed on the beam. So you could do away with that section of the truss. And what you end up with is the beam that you see here in the bottom, which is essentially the Kahn beam or the Kahn trussed reinforcing bar. At the top, you see the standard reinforcing bar. It's able to crack, and these cracks are able to propagate upwards through the concrete because it lacks these wings or these webs that you have in a truss that prevent that type of stress from propagating through the beam. So Julius then proceeded to test this theory out by building these combination beams and floors. And every time he piled the weight on top of the beam until it failed, it always failed right in the middle. And it failed not because the concrete cracked or broke, it failed because the steel that was contained within the beam reached the maximum stress and then snapped in half in the middle of the beam where the stress is the greatest. And that meant that the weight that the concrete and steel beam could bear could in fact be calculated because the strength was based on the maximum strength of the steel, not on the point at which the concrete would crack and break apart. And as you can see right here, you have a very happy Julius Kahn, pleased with the fact that his theory has been borne out. Now, there was a second problem that Julius set out to solve, and that was the problem of building the wooden forms that would contain the concrete while it was curing and hardening. And you can see that all of these girders and beams and joists that had to be included that would contain the reinforcement bars, that would entail a great deal of form work. So you see all these wooden forms that had to be constructed by many carpenters and used an enormous amount of timber to construct them. And it was it was essentially the greater part of the expense of building the concrete structure. And so he sought a way to eliminate all this wooden form building. And what he came up with was something that was quite ingenious. Instead of building all that form work, you just simply build a platform of wooden boards like what you see here. This is in the era before plywood was invented. So it was just regular wooden planks that were laid out. And then on top of those planks would be laid these layers or lines of hollow terracotta blocks. And between each line of terracotta block would be placed one Kahn reinforcement bar. And you can see in the end-on view what this would look like. You have the beams here. The floor is going to be up here as soon as you pour the concrete. And that's the finished floor right there. You have a floor with beams that are reinforced with the Kahn bar. And then you have these hollow terracotta blocks that serve the purpose of creating a floor that has beams, but is much, much lighter than if the entire floor with the reinforcement bars was constructed of solid concrete. So you have a much lighter floor and much less construction of forms. Here you see the actual floor as it looked when it was completed. Now this is a picture that I took of the Packard plant. So this floor is over 100 years old, and consequently the plaster that would have been covering up the bottom of the floor is all flaked off, and what you see here are these rows of terracotta blocks, and between them you see these beams that contain the Kahn bars that provide the support for the floor. And actually, if you look where the terracotta block is broken away, you can actually see the reinforcement bar is hidden quite well within the beam there. These are not reinforcement bars, these visible rusted pieces of steel. Those were pieces of channel steel that were embedded in the floor in order to allow for shafting to be connected to the ceiling, shafting to run the machines. So what you end up is something that looks like this. This is a steel reinforced concrete beam. Here's a steel reinforced concrete floor. It's flat on the bottom so that it can be painted white, reflects the light that comes in from the windows to the outside. The area between the framework pieces is filled with terracotta blocks. And in some cases, if the appearance of the building was important, you'd have a brick facade that would be applied to it. But the bricks really were there strictly for appearance purposes. They had no role in supporting the building whatsoever. So Julius, having patented his reinforcement bar, which you can see here in this picture, started his company, the Truss Concrete Steel Company, in the latter part of 1903. He began manufacturing these bars and selling them to construction firms, and they were very rapidly taken up as a very superior form of constructing with concrete. And you can see this is an ad from just a little over a year after he established his business. You can see how many offices he's already established across the country, because Julius was smart enough to know, based on his work experience in Japan, that in order to prevent copycats from imitating his system, he'd have to rapidly become a nationwide company and become the leading reinforcement providing firm in the business nationally, and have a reputation for his product that would prevent copycats from getting a foothold. The first factory in Detroit, or first building of any sort to be built with the Kahn system, was the first Burroughs adding machine company factory that was at the corner of 2nd Avenue in Amsterdam. It's no longer there. It's been torn down many years ago. But it was the first building to use Julius's Kahn system method. And you can see right here a big sign that says floors, roofs, and window lintels, Kahn system of reinforced concrete and hollow tile. Now, by 1906, Julius had established major offices throughout the country, and the purpose of those sales offices was to observe very carefully any newspaper articles about major factories that were planned to be built, and to immediately go into action to sell to these plant owners the system of reinforced concrete for their plant, to demonstrate that it was superior to the slow burning or mill construction factory, and could be constructed either at slightly lower cost, considering the savings in insurance, or at worst, the very same cost as a mill construction plant. And in 1906, Truss Kahn sales reps succeeded in selling to 3 different major auto companies the steel reinforced concrete method for constructing their plants. The first of those was for the Garford Company, which was a auto parts manufacturing firm in Elyria, Ohio, a suburb just outside of Cleveland. And Elyria did not have a major architect or engineering firm. And so when TrustCon succeeded in selling them the method of using reinforced concrete, they also recommended that they hire Albert Kahn as the architect. And there were two reasons why Albert would be a good choice. First of all, Albert had experience building automobile factories. His work on the Packard Motor Car Company plant. And second of all, Albert was one of the very few architects at the time who had experience working with reinforced concrete. So Garford saw that as a reasonable reason to hire Albert as the architect, and therefore they did so. Second plant that was built using TrustCon's reinforced concrete was the E.R. Thomas plant in Buffalo, New York. E.R. Thomas built the Thomas Flyer. It was a highly regarded automobile. And interestingly enough, E.R. Thomas the year before had actually built their first plant as a reinforced concrete plant, which you can see hiding just behind the newer building here. But because that plant took almost a year to construct, and TrustCon promised to have the plant up and running within a matter of 90 days, they decided to go with TrustCon, and also took TrustCon's advice that they hire Albert Kahn as the architect. And finally, the third building, the third factory was the Pierce Arrow factory, a huge factory, and also in Buffalo, New York. And they initially planned to have Lockwood Green be their engineers and architects for the factory. And just as they were getting ready to begin construction, Pierce Arrow's plant in Buffalo burnt to the ground, and they were immediately on the phone with TrustCon, invited them to design the plant, redesign it as a reinforced concrete plant. And they also hired Albert Kahn to come aboard as a consulting architect with equal authority to Lockwood Green. And Albert was required to approve every single drawing that was used to construct the plant, whether it was a drawing by Kahn's office or a drawing by Lockwood Green's office. And you see here one of these drawings signed by Albert as having been approved by him to use for production of the building. Now, at the same time, in 1906, the Packard plant expanded dramatically, having already constructed their building number 10 of reinforced concrete as a test bed for the process. It wasn't the first reinforced concrete auto plant. The plant built by Cadillac on a street in Detroit was, but they added two very large buildings, buildings number 11 and number 12. And Albert was the architect again for this. And TrustCon was also hired as the engineering firm and as the construction firm. TrustCon was hired both the engineer and the contractor for all four of these particular automobile plants. So what we have here between the three out-of-state plants, Garford, Thomas, and Pierce Arrow, 485,000 square feet of reinforced concrete automobile plant. Then you add in the Packard buildings 11 and 12, another 90,000, a total of 575,000 square feet of automobile plant space that was designed by Albert. It was engineered by TrustCon and constructed by TrustCon. And this was by far the majority of all new automobile manufacturing factory space in the US. Now that had a tremendous impact on the nature of Albert's firm. Albert Kahn's company in 1905 had 23 jobs total. Only 4 of those were factories. It amounted to 17% of his company's work. By 1907, the number of jobs going through Albert's office was doubled to 56, but 19 of those jobs were factories. It was 34% just by number of the number of jobs in his firm, and probably amounted to about 80 to 90% of his work by monetary amount. In other words, the revenue to his firm was probably 80 to 90% as a result of factories. Here are just a sampling of the factories that Albert was hired to design in 1907. You have some that were auto companies, some that were not, some that were out of state, Syracuse, New York City, South Bend, Indiana, and you had some that were in Detroit. But all of them were major jobs. Most of them were also designed engineering-wise by Truscon and built by Truscon. But clearly Albert's business had been transformed from primarily a residential design firm into a major national industrial design firm. And it was at this point that Albert's reputation was established, and he expanded from there as a designer of factories. And so there was no question that when Henry Ford decided to build his Highland Park factory, that he would hire Albert's firm to design his massive plant in Highland Park. And here you see the original plant, the original building, which was an enormous structure, and was also obviously reinforced concrete and built in a very short period of time, about 90 days, and was highly regarded because of the speed of construction, the efficiency of construction, and also for one other very important development. And what you see here is an enormous change in the type of windows that were used in the plant. Now, at first blush, that might not seem like an extremely important development, but it was for a number of reasons. First of all, the old windows were the standard double hung windows like you'd have in a house, which if you've ever had experience with those, you know that they're very cantankerous to operate, often get stuck. They require a great deal of maintenance. The sashes have to be painted to prevent them from rotting away or getting rusted. And the light that they admitted to the building was clearly not as maximized as you have with these new style sashes, which was simply a fairly lightweight steel framework that held these panels of glass in place. And they were very, very easy to ship, to install in place by unskilled workmen. They admitted the maximum amount of light. They had easily opened operable sections that allowed for maximum ventilation. And they were actually less expensive both to install and to manufacture than the older style windows. And that was an innovation that came directly from Ernest Wilby, the chief designer of Albert Kahn's office. He didn't invent the windows, but he recognized that they, as a new product, should be immediately adopted for factory work. By 1910, Julius's company, the Truscon company, had constructed over 5,000 buildings within the United States and Canada, which, when you think about it, is a tremendous number. You're talking about significant buildings, typically factories, warehouses, retail structures, large structures and important structures that were expected to last for many years. And it was important for them to be a fireproof type structure. Ultimately, Truscon was acquired by Republic Steel in 1935, primarily due to the depressed economy and the aging out of Julius and the other partners and managers of the firm. But Truscon remained an important company until the 60s and 70s, when Republic Steel sort of vanished from the scene. Now, going back to Albert's company now, we see that beginning in the 1920s, there was a shift in the type of manufacturing facility that was typically demanded for manufacturing companies. And the type of facility that was demanded was usually a large single-story plant that was now replacing the multi-story reinforced concrete buildings. But it's important to note that the design of these factories was in large part facilitated by products that Kahn manufactured, that Julius's company became the largest manufacturer in the world of these steel sash windows that you see that constitute the walls of these buildings, and also the end panels of these buildings are actually lightweight concrete panels that are constructed with a product that was also manufactured by Kahn called high rib. Albert developed some of the most innovative plants in the country. By the late 30s, he was building massive plants that could be used for manufacturing aircraft. Here you see the Glen Martin plant in Baltimore, Maryland, that used these enormous steel trusses to create these massive open areas that were not supported by columns. And by 1938, Albert's firm was designing nearly 20% of all of the architect-designed industrial buildings in the United States. The onset of World War II was a tremendous era of manufacturing building going on in order to provide the war material that was required by the US and other countries. The Detroit Arsenal plant in Warren, Michigan was constructed in a matter of months, and before the building was even completed, it was turning out tanks and constructed tens of thousands of tanks that were used by the US and the Allies during World War II. The largest plant under one roof in the world was the Willow Run plant that was designed by Albert and utilized an enormous amount of steel material that was manufactured by Kahn. And it was a unique plant in the sense that it was a dark plant or a blackout plant that had no windows, so it could operate 24 hours a day without giving its location away by the enemy perhaps seeing light coming from the windows in the event that the US came under attack from bomber aircraft. And so lighting was provided by these fluorescent figures that were used for the first time on a massive scale in this factory. Julius passed away during the war, November 1942, and just about a month later, Albert passed away as well. It's rumored that their high living style and risk-taking, smoking, drinking was what led to their death. But there's no truth to that at all. It's just that the family had a history of hearts that, when put under stress, tended to fail due to heart disease, and that's how both of these men died. Now, there's one more thing I want to tell you about that I think that will clear up some confusion. Sometimes people mistake these types of columns, mushroom columns or martini glass columns, as being some form of a Kahn-designed reinforced concrete structure, which in fact they're not. This type of floor, which had no beams required, was actually invented by Claude Turner, an engineer who designed and built the first buildings in the latter part of the first decade of the 20th century. And then as a result of some patent confrontations between Turner and some others who claimed to have invented something similar, a lot of different reinforcement supply companies invented systems that are very similar, but did not infringe on the Turner patent. And so you'll see a lot of different buildings that have this type of a martini top column, sometimes with and sometimes without a drop panel above it to be used for a flat slab floor. So it doesn't necessarily indicate anything having to do with Albert Kahn. By 1911, 1912, Truss Kahn had developed a unique system for this type of a flat slab floor, and so they often constructed buildings that had a very similar looking type of column. And want to put in a pitch here for the Albert Kahn Legacy Foundation. It's a organization that's dedicated to informing, honoring, and preserving those Albert Kahn buildings, the Albert Kahn companies, and the achievements and innovations of Albert Kahn and his company over the years. And we've conducted a number of educational seminars, and in the spring, we'll be having a very significant exhibit at the Michigan Historical Museum, which we hope that you'll all find time to visit and participate in. And if you have an interest, I'd certainly invite you to take a look at Designing Detroit. There's a great deal about Albert Kahn, much more about Roland and the design of some of Detroit's most significant buildings, some of the unique architecture that was designed in Detroit, Detroit being the leading architectural city in the country in the early part of the 20th century. So now I'd be more than happy to take your questions and see what comments you might have about what I've had to say here.
Yeah, thank you so much, Michael, for your knowledge and your time sharing with us. We do have some questions already came in. So I'm going to read it one by one and we can answer those questions. So the first question, was there pushback from their respective fields of engineering and architecture when Albert and Julius decided to establish their partnership? For example, might other architects have felt that Albert has was compromising his design freedom?
You know, there's a lot to that question. I see two parts of it. One is, was there reluctance to use reinforced concrete? The second was, how did architects react to the type of work that Albert was doing? And you could write a book on both of those, but in a sense, the reluctance to use reinforced concrete was primarily a reluctance that came from those trades that were being displaced by reinforced concrete construction. The major trade that was being displaced was the bricklayers trade, and they did everything in their power to dissuade people from using reinforced concrete. And the major way they reacted to that was by attempting to get municipalities, cities, states to pass laws or regulations that prohibited reinforced concrete buildings or required them to contain brick surrounded stairwells or contain brick exterior walls, or were required to use bricklayers at bricklayer union wages rather than hourly unskilled labor to pour the concrete. And in many cases, they were successful at preventing reinforced concrete, San Francisco being the most extreme example. That's a long discussion. In fact, I'm just completing a book now on Julius Kahn and reinforced concrete, and I covered that particular topic extensively in the book, and hopefully that'll be out in a couple of years from now. As for the second question, that's more difficult to answer. Many architects were jealous of Kahn because he was getting jobs that were $80,000, $100,000, $200,000, and Kahn was extremely well benefited by those large jobs, as opposed to the typical job that an architect would secure, which would be residential. So $3,000, $5,000, maybe $10,000 in work. And so not nearly as lucrative. Now, it may have been more fun, may have been more challenging. Some architects were far more interested in the design aspects rather than merely building a business and earning money. So those people just tended to go their own separate way from what Albert was doing. But I wouldn't say that there was any kind of animosity towards what Albert was doing. If anything, it was probably more jealousy.
Okay, the second question is, were there any related changes made in the ingredients of concrete and how it was produced to help make it stronger too?
You know, that's an area that is not my area of expertise. I can tell you briefly that what we call concrete today is made with Portland cement, called Portland because it looked like Portland stone, which is one of the original types of stone that was replaced by concrete or by cement. Originally, concrete was a natural concrete that was type used by the Romans many years ago. And then there were a number of developments in the science of concrete in the last couple hundred years. And pretty much where I pick up and know something about it is at the point where concrete is developed, it's invented, it works. And I think after around 1900, at some point along the line, faster curing concrete was developed, but I couldn't really tell you when or how. Most of the important developments were in the changes made to the steel reinforcement, pre-stressed steel, things like that.
Okay. Were there any incidences where the reinforced concrete floor sections were poured on the ground, cured, and then hoisted into place?
That was not a method that was used by Julius Kahn or his firms. There were a number of types of construction that were attempted. One of them by Ernest Ransome, where he built preformed pieces that were then erected on site to form buildings. But my understanding is that those were not successful as mass construction methods, which was the characteristic that defined Julius's method. That Julius developed a method of reinforcing concrete that just about any firm could use, provided that they had experience working with reinforced concrete. And it could be done repeatedly, that the results would be the same in every instance. And it resulted in a reinforced concrete going from an experimental type of method to a mass industry, where thousands of buildings were being constructed on a daily basis using the same materials and engineering.
Okay, and you mentioned that one of the two sisters worked in the company too. Do you know what she did?
Yes, as a matter of fact, Molly started a business with her father at the time that Julius and Albert was practicing and Julius was in school. And Molly started a business with her father that was a business that was oriented to making colored copies of architectural drawings. This was an idea that Albert had first had, and then he, over the course of a year, working with his father, modified some reprographic equipment that could accomplish what they wanted to accomplish. And they opened a business in Detroit called Multicolor. And Multicolor was in the business of making blueprint copies of architectural drawings. And it ultimately became, by the teens, the largest reprographic company in the city of Detroit. And it was in business until well after the 1970s, when it moved to the suburbs. And I'm not sure exactly what happened to it, but Molly's husband joined the business, and ultimately their son ran it until he retired from the business in 1976.
Okay, the next question. The Albert Kahn Legacy Foundation does important work that you can support and presents programming in which you can participate. Can you say more about what's coming up?
Yeah, actually, the best place to get that information, since I can't keep it all in my head, is to go to our website, albertkahnlegacy.org. And we have a place there where we have announcements for all of our upcoming presentations. We have, besides the exhibit that I mentioned, it's starting, I think, April 23rd at the Michigan Historical Museum. We give regular webinars or web lectures online. We just had one earlier this week by Dale Carlson, which was very interesting. You can actually access that, and the earlier lectures, you can access them either through our web pages, or some of them, I believe, are available on YouTube, and you can access them there and find out about the future webinars just by taking a look at our website.
Okay. Okay. Next question. Did Julius do the engineering work for the Imperial Hotel in Tokyo? And is that why the hotel survived in the earthquake in the early 19th century?
Yes, as a matter of fact, Julius's company, Truss-Kahn, provided all the steel reinforcement, and they did the engineering. But there was also, I have to give some credit to Frank Lloyd Wright, who appreciated the need to design the building in such a way that it would be earthquake proof. And he incorporated some unique ideas into the design of the building. And there's actually a paper out there, I forget the name of it, but if you Google Truss-Kahn and Imperial Hotel and Frank Lloyd Wright, you should be able to find and download that paper. And it's not too lengthy, and it's very interesting, and it's very detailed and well researched. And that'll provide you with extensive information on the design of that building.
Okay. And I think that's all the questions I saw in the Q&A box. Let me just quickly check if there's anything in the chat. Okay. Okay, we might have one question here. Okay, it says, I'd like to hear your thoughts on why Albert Kahn is so little remembered in architecture. Folks might know that Julius Kahn, but why Julius did not use his name in the company name, and where Julius received his engineering education.
All right, well, let me do the easy ones first. Julius received his education, as did his two brothers, Moritz and Felix, at the University of Michigan, their School of Architectural Engineering. And he did not use his name in the name of the company because he used the name of his product. He invented the trussed concrete steel reinforcement bar. So he named his company the Trussed Concrete Steel Company. Later changed it to Truss-Kahn, shortened version, obviously. But the reason he changed it was because by that point, he had come up with so many different inventions that were not reinforcement bars that he felt the need to change the name of the company to Truss-Kahn Steel Company. He was producing hangar doors, complete steel buildings that you could order right off the shelf and put up in a matter of 2 or 3 days. Just so many different products that I can't even describe them all. He had over 76 patents in his lifetime. Many other people within his company that were hired on because they were inventors and innovators had patents as well. It was just a complete environment of innovation, invention, and because they also had a subsidiary construction company, they were well aware of all the problems and potential inventions that came from their work out in the field in constructing buildings. So the minute they would discover a problem or a spot that needed improvement, they would come up with an invention that solved that problem and patent it and then market it as a new TrustCon product. So ultimately, they were even in the business of selling pressed steel beams, which replaced rolled steel I-beams. It was a very successful product. So they were essentially competing with themselves, and the more they did so, the more successful they were. Now, the question of why, as I understand it, why wasn't Albert more famous, more well-known? This is obviously my opinion. So my opinion is that in the post-war years, the architecture field in the United States, which had been tremendously vibrant and creative and innovative up until 1930, had essentially been demolished. You had people like Rowland, you had certain architects in New York, other architects throughout the country that had come up with a tremendously successful, simple, elegant style, which we now refer to as Art Deco, that had been developed during the 20s. Then the recession or the depression, Great Depression hit, and skyscrapers, which were the chief recipients of that architectural style, were no longer built. They weren't built for the entire period of the Great Depression and the entire period of World War II, and for quite a while after World War II. So all of the designers, building designers that had been trained and had practiced in that style, by then had retired, had died, had left the profession and gone into some other field, maybe construction or sales. And that left the American architectural firms sort of rudderless. And at the same time, the young architects that were coming up were in awe of the European architects, Gropius, Mies, and others, who were very unusual in their designs. Their designs are purported to have been inspired by Albert Kahn's factories, which is something that would have appalled Albert had he known that people were using his factories as a template to design public buildings. But what you ended up with was the international style, a very bland, uninteresting style that's essentially a inexpensive steel framework covered with the most inexpensive material that could be had, glass. And that's what became the style of the era. So because the European architects were now the architects of choice and they were the famous architects, they were the ones that got all the attention for many, many years. And it's really been in the last 10 or 15 or 20 years that Albert has begun to become more well recognized because of an much increased interest in the urban environment. You see the modernist facades being stripped off of buildings and the older facades underneath being resurrected or imitated, because people have become much more interested in the older styles. And I think that's the reason, both for Albert being ignored and for Albert's reputation finally being brought to the fore once again.
Okay. Yeah, I just want to read that one comment from an audience that Thank you, and you explained this complex development simply and completely. And yeah, thank you so much, Michael, for your time today. And thank you, everybody, for participating in our webinar. This webinar is being recorded, and you will receive a link by email when the recording is available. And feel free to share it with people that you know. So if you would like to check our past webinars and attend our future webinars, please check our website at www.mhpn.org. Our next webinar is scheduled for February 10th, and we will have Brian Yup, Director of Programs and Operations at Motor Cities National Heritage Area, and Steve Shotwell, Chair and Board of Trustee at Ford Paquette Avenue Plant, to talk about how the Motor Cities National Heritage Area Challenge Grant Program can work for you. And we